these formulas, more often than not, aren't rearranged, but they can be, right? Because any formula can be moved around, yes? So say I wanted to replace like a 2 cos squared x, I could technically replace it with 2 cos squared x would equal cos 2x plus 1. Right? Like all these formulas can be rearranged. This one, I could divide the 2 over. I could get 1/2 sine x or sine 2x equals sine x cos x. So all of the formulas can be rearranged. These are double angle identities. Sine 2x is nice, it only has one option. Tan 2x is nice in that it only has one option, but it's fractions. Cos 2x is a lot of options. So with cos 2x, you make an educated guess which one you're going to take. So for example, if the rest of my question had coses in it, and I just wanted to keep coses, then I would put in this one, 2 cos squared x minus 1 instead of cos 2x. You can't factor with a cos 2x. You can't factor with a sine 2x. So if you want to factor, you have to replace those with the other parts of it so that it is factorable. Okay? There's no way you can factor a cos 2x. That is not the same as a cos squared x. They are different. All right. So those are our formulas that we can use as well, the double angle identities. 1 sine, 1 tan, and 3 coses. They're also on your formula sheet. Bless you. They are down here. So we did the Pythagorean ones here. Here's the double angle identities. These are the sum of difference. Those are the only ones we have left to go for. But we won't do those today. All right. So let's look down here. I have cos 2x. This is my problem. It's my problem child. Can't factor with it. Can't solve with it. Yeah? I know that right away. Then I have plus 1 minus cos x equals 0. So I know that the cos 2x needs to go away so that I could possibly do something with this. What's left in this question? 1 minus cos x, correct? So which of the 3 double angle identities would I use so that I would just have coses? The first one was cos squared sine squared, the second one was cos squared, and the third one was sine squared. Second one was cos squared, right? So I'm going to replace it with 2 cos squared x minus 1. So that got replaced with that. See, those are the same spots. Then I have the rest left over. Plus 1 minus cos x equals 0. What do I do next? I collect these ones. Negative 1 plus 1 cancels. So I'm left with 2 cos squared x minus cos x equals 0. The moment I have a squared, I have to get it everything to one side set equals 0. Every time I have a squared, right? Then if the coses are overwhelming, if you take cos out, cool. If the coses are overwhelming, go let m equal cos x. And we get 2m squared minus m equals 0. What happens if you don't do a let statement and you just start using m's? You can get full marks? Nope. You need to tell them what m it represents, right? Now I can take an m out. I'm left with 2m minus 1 equals 0. So I get m equals 0. And 2m minus 1 equals 0. 2m equals 1. And m equals half. Now, if you make it not m, a lot of the time people will box it because they're like, oh, sweet, x equals 0, x equals a half. We're so used to getting those, you box it and move on, right? The reason why I picked an m is kind of a weird variable. It's not used very often, right? So it'd be like, wait, there was no m in this question. So I have to go back and say cos x equals 0 and cos x equals a half, which both of these are on the unit circle. So I don't have to do reference angles at all. Where does cos equal 0? And why did you know it was 90 and 270 degrees? Why did you know to do that instead of pi over 2 and 3 pi over 2? The domain is in degrees. And I have to have answers between 0 and 360. So this is 90, 270. And then where does cos x equal a half? Positive a half. 60 and 300. This is where Calgary Stampede, right? So we have x equals 90. I'm going to start with 60 degrees. $90 degrees, 270 degrees, 300 degrees. Yeah? Okay. What if I change the question to be from negative 360 degrees what if I change the domain to that? Do I do the question any differently? No. I still find all my answers between 0 and 360, correct? Now what do I just do? Yeah, minus what from them? 360, because I just need to get their coterminals that land between 0 and negative 360, right? So I don't do the question any different if the domain is restricted weird. I find from 0 to 360, and then I find their coterminals that fit in that actual domain. So I would go 60 degrees minus 360, and I get negative 300, which makes sense because negative 300 would be 60. We agree? Does that fit? Yes, so that would be good. Then I do 90 degrees minus 360 equals negative 270 degrees. 270 degrees minus 360 equals negative 90 degrees. And 300 degrees minus 360 equals negative 60 degrees. And then that would be my solutions. Do we see the difference? And if I ask it from 0 to 360 or negative 360 to 0, I would do the exact same steps. I would not have boxed that, obviously, because it would not be correct. I would have found my answers, then boxed that. So the answer to this would be negative 60, negative 90, negative 270. They're not always just negative of each other. These just happen to be because the angles landed on the same spots, right? But you don't just make these negative. Please don't assume that's what we do. Yeah?
Do you always do it from greatest to least?
No. You can do it from whatever you want. They'll often go from least to greatest. But if you put them, as long as you have all the same answers, it doesn't matter what order. Okay? So for the next question above, I'll come right back to this. I want you guys to try this one out. Now this one's a sine 2x. You only have one option. See what you can do. See if you can figure it out. It's a little bit different. It's not a trinomial factoring or anything. Cos x, replace this with sine. 2 sine x minus 1. You could do that, correct? That is an option. Or, I'm going to caveat that, pull it out. You could go let m equal sine x. You could go let n equal cos x. And you could go 2mn minus n equals 0. Take an n out. 2m minus 1 equals 0. N equals 0. 2m minus 1 equals 0. N equals a half. What they do want to see, just so you know, because I like skipping this step. I just hit the board with my hair. Is that you do write that this equals 0 and this equals 0, but then you can skip to n equals a half. They can see how you can do that, but they want to see this step, and I like skipping it. They want to see it. So show that step, and then if you can go to n equals a half and not show that work, whatever. But what they tell us when we go through and we mark and stuff too is if we can see from step to step to step to step how you would get there, fine. But if you go from like one thing, like 2mn minus n equals 0, and you tell me n equals 0 and n equals a half, that's too many steps skipped. I can't see how you could easily go from there to there, right? You know what I'm saying? All right. So we have cos x equals 0, and sine x equals a half. Cos x equals 0 we've already done, here and here. And then sine x equals a half in the positive sign quadrants, quadrant 1 and 2, at the 30-degree reference angles. So we go back, and we always check what the variable is. So a lot of people will write x equals, but the variable was a theta. Although write theta equals, but the variable was an x. So always go back when you go to write your answer and be like, okay, the original variable was x. Okay, x equals 30 degrees, 90 degrees, 150 degrees, 270 degrees. So always go back and make sure you're actually giving the variable. Because that's a place where you can lose marks, right? You don't want to lose marks. So when I'm being crazy about like this and look at this and this and this, it's because I want you to get full marks on your written response. That's why. On the diploma. All right. Now we got a whole bunch more hoopla. Hoopla. All right. We're also going to get denominators. Okay, circuit grade 11. Put down your pencils. This is not actually what we're doing today, but we're going to go back to grade 11 so we can understand why we're doing what we're doing. So in grade 11, we would have like x plus 3 over x minus 2. I obviously know we're doing with tans and coses right now. But whenever we had rational expressions, we always had what? Anyone remember? We had to do something before we could even do the question. If we added them or subtracted them, yeah? Non-permissible values, and why? Yeah, this whole denominator here can't equal 0, correct? So any x value that I plug into that denominator that would result in making that denominator a 0 would be a non-permissible value. We agree? So what number could I put in for x here that would cause me problems? 2. So I know that x can equal 2, correct? Or my denominator would be out to lunch. And when we learned to solve rationals last year, we always had to check that our answer when we solved it, x equals 5, x equals half, x equals 2, wasn't your non-permissible value, wasn't your restriction. Because if it was extraneous, right? And sometimes that did happen. Sometimes the non-permissible values were plus or minus 3, bless you, bless you. And the answer was 3, and then you'd say, can't happen, extraneous, right? We wouldn't say can't happen, you'd use extraneous, but you get the point. So why am I talking about that? Well, did I just go ahead and set it back? Well, it's because we have a cotan sitting on this page. So, for the most part, when you go to solve, you want to always have sines and coses if possible in tans. If you have cosecants and secants, it's often easier if you switch those to sines and coses, you're like this better. So I have a cotan on my page, so that's the first one I'm going to deal with. So I'm going to say, okay, cos squared x equals, and what's cotan x the same as, guys? I switch it to cos over sine, not tan. If I switch it to 1 over tan, does it get any better? No, now I just have a tan sitting there with the cos and the sine, and it's really confusing. So we have our formula sheet. It's our best friend. Go to our formula sheet, yeah? Cos over sine. So we have cos x over sine x times sine x. And I immediately say, oh my goodness, I got myself a denominator with a variable in it. And when I have myself a denominator with a variable in it, what am I going to get? A non-permissible value. That's exactly what we get. A whole bunch of them. So, what is in my denominator currently? Sine x. So I need to find all the spots where sine x equals 0. All the x values, all the degrees, right? All the degrees where x would equal 0, or sine would equal 0. Because I'm looking for an angle, correct? The x is sitting beside the sine, and if it's sitting beside the sine, that represents angles. So I'm looking for all the angles where sine x would equal 0. Where does sine x equal 0? 0, 180, 360. Oh, I can go the opposite direction. Negative 180, negative 360. Right? For life. Do we agree? So how I could represent that as a general solution is I start with my very first one. What is my very first one? X can't equal 0 degrees. Right? Now I want to, can I do this one with it? Sure. How long does this take to get there? 180. How about here? 180. How about here? How about backwards? How about this way? How about this way? So if I add 180s to it, or I subtract 180s from it, I'll get every single x that can't exist. We agree? So I go 0, x can't equal 0 plus what? 180 degrees, n, and what does n have to be an element of? Integers. Do I need to write the 0? 0 degrees plus. I have to write it because it's my first angle, but are they going to write it in the answer? They won't go 0 plus. They'll just write an answer of x can't equal 180 degrees n, NEI. So that's the general solution NPV, correct? Do I need the general solution if they give me a restricted domain? I just need to check for extraneous roots that fall between 0 and 360. Yes? So what do I know my restrictions? For this particular question, what can't they be? That's a general solution. Non-permissible value. Restriction. This one would just be x can't equal 0, 180, and 360. What's the catch with 360? Do we even have to list it? No, because it's not even in the domain. If I list, I'm not wrong, but it's not even in the domain. So the restriction of the domain would be. We all agree? Cool beans. Did you guys all see that I posted review podcast for polynomials in chapter 4? Okay. All right. Sin x and sin x cancel, don't they? One in the denominator, one in the numerator. Oh my goodness, I'm left with only coses. Huh. Life is so good. What do I do when I have a squared and coses? Well, I can let m equal cos x. So I can go m squared equals m. Do I divide an m over? Do I ever do that when I have a squared? When I have a squared, my first step is always to everything to one side, set equal to 0 every time. So, then we got into all right. Woo. Whoa, don't know what I'm pasting. Kind of scared. Okay, it came up and let me push it. I don't know. Nothing. I'm pasting nothing, it seems, because I didn't do anything. It was probably just from random post from a textbook. Where I'll steal a screenshot from a textbook. That's all you would really get. That's sort of as riveting as my life is. All right, take an m out. We're left with m minus 1. We get n equals 0. M minus 1 equals 0. M equals 1. So we get cos x equals 0. You want to know the saddest of day when you mark these and someone let m equal cos x and they put sine down here? Oh, it's just so sad. It does happen. It's a sad day for all of us. Me marking, you getting the mark. It's just all right. Cos x equals 0 when x equals 0, which is boom, shaboom. And then cos x equals 1 here. Boom. So cool. My answers are x equals 90 degrees, 270 degrees, 0 degrees, 360 degrees. And I'm wrong on 2 accounts because I didn't do 2 things. Why am I wrong? First off, the restrictions here would kick out 0. They're not kicking out 360 because the domain would kick out 360, right? So, if I wanted to do this, I would not do that. Hope you're using pencil. All right, x would equal 90 and 270. And x would equal 0 degrees. I wouldn't even put 360 because the domain kicks that out. I would circle it. What would I do? Put a line through it, reject it, and say extraneous. And why is it extraneous? Because it is a solution that happened. It worked. It existed. But it can't work in the question because it's a restriction. Because if I typed that into this, if I put 0 in here, my calculator would error me. Right? Why? Because cotan of 0 is what? Undefined. So it would kick it out. Okay? So when you would plug y1, y2 in like we did yesterday, these would be the only two solutions that would come out. That one wouldn't come out because it's extraneous. So some people say to me, well, and they used to do this a lot, they used to say, what is the extraneous solution? Because your calculator can't take an extraneous solution out. Problem is with that, and I don't like, is they're asking you to find a solution that doesn't exist. They're not actually asking you to solve anything. Tell me which isn't existing in the world. Okay, you guys try B.